Hey, what's up? Rocaford FPV and more here, and today I'm going to demonstrate my proof of concept non-GPS throw mode. So it's using the onboard rangefinder. It could use the barometer. I just find that the rangefinder is a little bit more accurate with the way that I've coded this. And so I'm going to demonstrate a couple different throws, and then we'll walk through the code and see what you guys think. So I'm using a TBS Tango 2 for my radio, and I have throw mode tied to my back right's momentary switch. I also have a Lewis script written, so normally I'm using barometer for altitude, but the Lewis switch or Lewis script is tied to the switch to use rangefinder for this throw mode. So essentially what's going to happen is I'm going to do a couple different throws. The code detects different velocities of the throw. So if I just have a small toss versus a large toss, it'll output different motor thrust. So once I launch it, there's really no position hold. I do have an optical flow sensor on here, but sometimes I don't trust it depending on the texture of the surface. So the intent is to just do basically kind of a DIY altitude hold in code, but the intent is for the pilot to take over as soon as possible. So I'm going to switch it into throw mode here. Sometimes I get a position estimate error because I think that the code's still kind of looking for that position info from the GPS. And so I'm not like a true developer, so I'm just kind of working around it. Eventually the error goes away and I'm able to arm. And so here's just a gentle toss. It's in kind of an altitude hold mode, so now I'm going to take over and stabilize. So I'll do it again. Turn on throw mode. Take over. And then I can fly it. Okay, a couple other things I can do with this. Arm it. Throw it out sideways. You can see in the background, hopefully, that it had an altitude hold mode. All it's doing is just adjusting the throttle output based on the hover throttle and the distance that it's detecting. So let me back up here and maybe you can get a better view. So those were just gentle tosses. Again, a gentle toss here. Just walking with it. Okay, and then I have coded in there, it detects more aggressive throws. So more aggressive throw is going to output a more throttle on the initial throw so that you can rapidly clear obstacles. So let's try this. Further out. And then bring it back in stabilize mode. You know, maybe you had a mission loaded up and you just wanted to throw, launch it, and then send it on its mission. But anyways, that's throw mode without GPS. Let me know what you guys think, and I'll cut the video here and then we'll go through some of the code and show you how it works. Thanks for watching. Alright, so let's take a look at the code for the mode_throw.cpp file in the ArduPilot code base. So there is a lot of changes that I made here. There's a lot of changes I made here. Some of them are really small, some are major, so I'm not going to go over the small code changes. You can just kind of go through this on your own. What I would like to do here is go through some of the major changes. So let's go ahead, we'll scroll down here. I've tried to comment a lot of this here. So for example, here I added some comments like, all right, what are the assumptions for what's going to happen, some of the prerequisites, what are we actually going to do, and then what are we going to do next. That's just kind of how I think through this. It kind of helped me debug some of this. So a lot of the framework was here as far as the throw state machine. So first you're going to be disarmed, then you're going to be detecting a throw. Once the throw is detected, then the vehicle is going to get uprighted, and then the vehicle is going to have its height or altitude stabilized, and then it's going to go into a position hold, and then finally it's going to go into the desired mode that's either set in Mission Planner or the default if one is not set. So what I've done here is I've kept those that state machine and just kind of worked around it. And so, for example, here nothing has really changed. We are waiting for the throw, and then okay here, so we're detecting a throw. This is where some of the code has changed. So if I go down to this function here, something that I've done is basically added in a variable for a high-speed throw or a low-speed throw. So basically, if the pilot just kind of gently tosses it like in the video, or aggressively tosses it, it'll dictate the motor output. So if you want to throw it high, you can throw it high. If you want to throw it low, or you just want to kind of just have it raise out of your hand, I kind of built that variation in here because, at least for me, and I understand it's kind of a niche group, but I do like having those options. And so what I'm doing is I'm pulling that value from Mission Planner. So the user is able to set those conditions. And so if we look here in Mission Planner, these are now exposed to the user. So unfortunately, the descriptions didn't get pulled over, and I think that's just kind of my limited knowledge of how all of this works. But here, throw toss speed low, so 0.5, that's basically, it barely has to move in order for it to launch. And it's kind of a risk that you run, because if you arm it and you inadvertently move your hand up, it's going to launch. But hey, that's just kind of how I designed it. And then 4, I think the default value in the code base was 5, so I lowered it to 4. Really, 5 I thought was pretty aggressive. 3 I thought wasn't aggressive enough. Really, this is just a very scientific process that I followed to find 4. So let's go back to the code. So it's going to detect whether or not it's a high speed or a low speed throw or toss. If it's good, then we're going to basically just go straight to it. There was a little bit of other code in here as far as the timing, the altitude compared to home. I just removed all that because we're not using GPS, and this was just a very simple use case for myself. Okay, so the throw has been detected. The assumption is the pilot has started to throw the vehicle. Now we're going to basically allow the motors to spool to the unlimited. Nothing has changed there. Okay, now the vehicle needs to be uprighted. This is where I've changed quite a bit of this code. So if we go here to the uprighted stage, what I am doing is I am basing everything off of the hover throttle. So if it's a high-speed throw, we're going to multiply the throttle by a certain value. If it's a low-speed throw, we're going to multiply the throttle by a different value. And this is in Mission Planner again. So high speed, or throw toss speed high, is going to command a throw multiplier for high at a 1.5. So 1.5 times the hover throttle, or for a low speed throw, 115% times the hover throttle. So that's kind of what you saw in the video. So this all depends on a very solid hover throttle value. If you leave your motor hover learn to 2 and it's constantly changing, and you're not changing the weight of your vehicle, or you're not using new batteries, I would recommend just putting that on disable if you wanted to go with something like this, because this is built around a solid hover throttle value, and if yours isn't solid, then this isn't going to work very well. But again, it's proof of concept. Not everyone's going to use it. It's a niche population. I'm just thinking out loud of the things that I've come to find. So based on the high speed or low speed throw, it's going to use that multiplier, and so we're going to calculate what that is, and then we're going to tell the vehicle to set the throttle, and it's going to launch with that throttle. Now it's going to launch indefinitely, so we need to account for that. So let's go back to where we were, and here. So the vehicle is now launching. What we're going to look at is we're using the rangefinder. I don't want to use the barometer in this case because the massive amount of ground effect and prop wash from the hand launch to when it's in the air, the barometer is just going to be going crazy, and that's what I've found. So I'm using the rangefinder. It's more accurate. what we're going to do is the vehicle is launching, and as long as the vehicle is continuing to ascend, let's go ahead and just reduce the throttle. What this is going to do is it's going to force it to apex and eventually begin its descent. So once it begins its descent, then we're going to go ahead and we're going to move to the throw stabilize, the height stabilize stage. So it's going to continue to climb at that 150 or 115% throttle output, and we're telling it, hey, okay, that's great, have your fun, let's come back to Earth. And then once we're coming back, now we're going to use the highest altitude that it reached as the target altitude, so it's apex. So essentially, as high or as low as the pilot wants to throw the vehicle, that's its target altitude, and it's going to try to maintain it. Now, what I found is switching straight into altitude hold mode, for whatever reason, doesn't work, and I think it's because the weight of the vehicle, gravity pulling that vehicle down, altitude hold mode just cannot overcome the weight of the vehicle. So what we're doing here is we're basically just playing with the throttle. So we're looking at its current altitude and we're saying, hey, what is the current altitude based on our target altitude, and do we need to adjust it? So if we are higher than the target altitude, then we're going to cut the throttle. If we're lower than the throttle altitude, then we're going to increase the throttle. But if we continually increase the throttle, we're going to go straight into space. Well, maybe not space, but if we continually cut the throttle, we're just going to crash into the ground. So we're limiting ourselves to what our throttle can actually do, and that's up here. So it's based on our throttle hover, 7.5% of our hover throttle up or down. Those are our upper and lower limits. So we're governing how much we can actually increase or decrease the throttle. That's why it's important we have a good solid hover value. So based on the altitude, we're either going to cut or we're going to increase the throttle until we reach the target altitude. And if the target altitude is good, throw height is stabilized. What I have here is basically it's got to be able to do this DIY altitude hold for at least 1 second before it moves on. So if you had like a pre-planned mission here, we'd probably want to get rid of this. This 1 second thing is really just gives the pilot time to take over, because if it's less than a second here, this isn't gonna execute. If it's less than a second, it's going to come back up here and it's going to try to maintain that altitude. That 1 second is going to give the pilot time to switch to stabilize mode and be on their way, switch to altitude hold, the real altitude hold mode, or switch to loiter. It gives the pilot some time before the vehicle starts to just to do some crazy stuff. So anyways, that's a look at this code. Another thing I did is I added in the alt hold mode possibility. It doesn't show up here as the next mode. It's still the default values, but I am able to tell it to default to 2 for alt hold mode in the parameters code. So that's a quick look at what I've done as far as the proof of concept throw mode without GPS. Let me know what you think, and hopefully someone can benefit from this. Thanks for watching.